So, good afternoon, everyone. So today I'm going to talk a little bit about the portal architecture at NTT/Dimension Data, how we got there, and some lessons that we learnt along the way. So first up, I just want to introduce myself, give you a little bit of history about my background. So I'm Stuart Campbell. I'm an architect at NTT Limited with the Global Services R&D team. So my focus is on portal and common services architecture. So basically stuff that goes across multiple towers, multiple business units, those sorts of things. So how did I end up here? It's an interesting question. So I've been with NTT/Dimension Data for 9 years now. I actually started as a NOC engineer, answering support emails. I then did software support for a couple of years, and I ended up in our global team as a systems analyst. And I was lucky enough to end up in a project for a new client-facing portal. And then through my work in that project, I ended up as the solution architect, much to my surprise as well. So what am I talking about today? So what I want to talk about a little bit is the history of our portal, which we call Managed Center, the context in which it was built and the initial architecture we had, the lessons I learned from building Managed Center that maybe resonate with some of you here today, the problems that we have with the current architecture, which there are a few, and how we want to evolve that architecture to move into my favorite new buzzword, cloud native world. So where did Managed Center come from? So the part of the new entity family that I came from was Dimension Data. Some of you may have dealt with us in the past. We're historically a support attached services business. So we'll sell you a box and we'll monitor that box for you for, just a small fee. But, we see the same things that everyone else sees, right? Everything is software now, right? No one's going to buy a hardware box and ask you to monitor it anymore. And everything is a service, right? CapEx to OpEx. So the project was initiated towards the end of 2013 as part of a drive to move to more managed services businesses, starting with a managed service for data center tech. Obviously, we're not the first group to come to that party. In fact, we were one of the last to come to that realization. So we needed a way to differentiate ourselves in the market. And the decision was made to focus on user experience. Now that sounds pretty pat, kind of differentiated today. But I can assure you at the time in the company where we were, this is revelatory information that we should focus on the user experience. So Managed Center was born. So what do I mean when I talk about user experience? So hands up here if you have or currently use ServiceNow as part of your service management platforms. Now, I'll put my vendor management disclaimer here so that I don't get struck down from above. We love our friends at ServiceNow, but they're not a beacon of user experience, let's say. So whilst it's quite functional, it's not a big differentiator, right? Everybody has or knows about ServiceNow, and it's not very nice, right? So we wanted to go from this to this. As you can see, we had dark mode before it was cool. So, history of development. So when we started this journey at DD and NTT, we didn't have a lot of web dev skills in-house. We're a systems integrator, we're really good at stitching stuff together, not so good at being a software company, at least at the time. So we needed external help. So we hired a company based out of the UK called Prospect to help us design the user experience, and worked with an outsourcing company based in Melbourne and Sydney to do the actual development work. So it was a very small team. It was 4 devs, 1 UX designer, and 1 systems analyst, which was myself. We released a POC at the end of 2014, at which point management said, well, that looks pretty cool. Can you put that in production, please? Big mistake. And the first version went live in prod in March of 2015. Remember to press the button, Stuart. So the first lesson that I want to share, and again, it seems pat, but I really believe that this is one of the key reasons that we succeeded in this project, is having the right product manager is critical. It's absolutely critical. It wasn't a quick process for us to go from business requirements to a working system. It took us about 15 months, which again, sounds horrific, but believe me when I say in Dimension Data, that was really, really fast. And our product manager was key to that success. So they had a direct line of reporting to the execs that were sponsoring the project. They could give us the protection and the freedom to do the work that they knew needed to be done and give us that feedback loop. All right? If the execs wanted something, they only had to talk to one person. They didn't have to go through multiple layers of product management or any management to get to the dev teams. So we were given the freedom to deliver the things that we knew needed to be done. Most importantly, though, is this product manager is not a technical person. But what they did do was listen to the technical feedback that they were given, push where they felt like the functionality was key to what they wanted, and also listen and go, okay, you know what? That sounds really hard. I don't want to invest all of my time doing something that's really hard that's going to give me incremental value. They didn't mind hearing that something was impossible, but you did have to be able to explain why. So that's lesson one. So the historic architecture. So it's a fairly standard web application. Red Hat VMs, Docker containers, Nginx, Java, Vertex, which is our message bus and internal application structure. I'll get into that in a sec. Shiro for security, JavaScript, and all hosted on VMs and using CloudFront to deliver stuff, right? So there's nothing revolutionary there, right? Got a couple of VMs, you've got some containers, you've got Nginx doing load balancing, all sits on top of a cloud platform. Now what's interesting is the Vertex framework. So what Vertex allowed us to do was, even though we were nowhere near mature enough to start a microservices discussion or a microservices journey, we could still use some of those design patterns using a concept that Vertex calls verticals. So within our monolith, we have little verticals that all talk over a message bus that do one thing and they do it well. On the front end, again, it's nothing special to what we have today, right? So it's AngularJS, it's jQuery, it's Bootstrap, and a couple of special purpose tools that lets us do styling and charting and those sorts of things. So that's the architecture that we had. That's the architecture we've had now for a couple of years, but it's pretty clear that where we are today, much more mature, much further along our microservices and DevOps journey, and scaling out development as we've started to do. We run into a few problems. First problem, it's a monolith, guys. The app was initially built on a Java backend, right? This is because, like I said, we didn't have a lot of developer experience. We didn't have a lot of web development skills, web design skills. We took the tech that the guys knew and we built on top of it, which was great to get a prototype working. But like I mentioned, when we showed that prototype to the execs, they're like, that looks cool. Put that in prod, could you please? You've got 3 months. So we ended up with something that's quite large and quite difficult to manage and support. And as we scaled out our dev teams, as devs rotated in and out of the project, we brought it in-house, we hired new people on board to do support, we found that it's just impossible to teach the complexity and the interactions inside the monolith. Adding new features, it inevitably creates regression because it's just too complicated. You can't reason about the change that you want to make. So that's problem number one. Problem number two, there's no reusable components or shared code. So again, was built by a really small team, not very familiar with the web space, in a time before we had Angular 2 and React and Vue and all of these really nice component-based frameworks. Because of that, features aren't built in the most architecturally sound way. So, for instance, we have around 30, 35 charts in Managed Center today. All of them have their own JavaScript file, and 90% of the code in those files is exactly the same, except for the query that says, what data do you want to actually get and show on the screen, right? That's obviously a horrible way to do it. And it means that if you want to add something to charts, say you want to be able to add filters, which is a feature that is still in our backlog today, you have to do it 30 times. Or you have to spend the time to completely rebuild your chart engine, which is what we're doing today. Now, that's obviously not an ideal way to allocate your resources. It also means that you can't share things across teams. So NTT recently, get a bit of internal politics, recently brought together a bunch of their different services organizations under one banner. That means we now today have something like 23 client-facing portals across the business, and none of them can share stuff with each other. So I can build a really cool chart in Managed Center, but I can't give it to someone else to use. They can build a really cool network map, and I can't use it in Managed Center. So that means that we get a lack of consistency in the UI. We get poor UX because your incident chart calls one system, mine calls another. Client calls up the service desk and is like, how come these two charts don't have the same number? So it inevitably means that the user experience is bad. And we can't leverage our development in different contexts. So lesson 2, web components are really cool. You should use them, please. It seems obvious, but without a strong development history in the web and frameworks like Angular, we didn't take the best approach we could. So that's lesson 2. Problem number 3, development bottlenecks. So we started with a team of 4. That team is now 15 developers, 2 DevOps engineers, which John will hate me saying out loud. And 3 Scrum Masters, 2 product owners, a product manager, dev leads, the works. But it doesn't matter how much we scale that team out, the amount of work that comes in from all the different parts of the business that want to show stuff to customers is just going to grow far beyond what we can scale to. So we need a way to democratize components so that they can be plugged into an architecture, so that those things can be developed by the teams that know them best and can be delivered by the teams that know them best. You can't get end-to-end value out of a feature if, when you've done all your development, you still need to wait for the portal team to render your chart for you. And problem number 4. Currently, Managed Center is locked to only a few supported tools that it can extract data from. So ServiceNow, I mentioned already, a series of monitoring tools that we use in the back end, Elasticsearch, SQL analysis services. But if you come to me and say, we've built this cool new managed comms service, uses prognosis, I can't take that data and render it in Managed Center. Now, that's a real problem for user experience, because if I've tried to sell a networking service and a comms service to a user, I don't want them to have to log into 2 different places to get this information. I want it in the same place. But because of the architecture that we have, it's very much point-to-point integrations with all of these systems. So what do we want in a portal architecture? So we want something that follows the microservice and micro front-end patterns. And for those who haven't heard about micro front-ends, I'm going to touch on that in a minute. We want something that's easy to contribute to if you follow the standards. We don't want to be the bottleneck for development anymore. We need the ability to surface data from new data sources quickly. If we get a new tool, acquire a new company, spin up a new service, we need to be able to plug that into our portal architecture as fast as possible. And we need interfaces that have a consistent user experience. So when I presented those points back to my boss, he said this to me, well, that's nice, but how do we get there? So for me, it starts with what I've come to believe are the three key conceptual models for a client portal, or any portal really. An entity model, a charting model, and an action model. So with these three conceptual models, we can build and design and develop any component that our portal is going to need in the future. So let's start with the entity model. This is the most important. So I'm not sure how easy it is to read. Pretty difficult. The entity model is about classes and relationships for anything you might want to view data about. Could be an incident ticket. Could be the CI that's related to that ticket. Could be the performance statistics we've gathered about that CI for that incident. It could be any change tickets that have caused that incident. The key here is what I termed the object-oriented query endpoint. You need a single place where you determine this is what a CI looks like. These are its attributes. This is what an incident looks like. These are its attributes. And not only that, this is where you go to get that attribute. And it's important to note that this isn't just about one user interface. This is about many user interfaces. This is about the business logic living in an API layer rather than in your UIs. So you can throw away your UI and build a new one. Next is the charting model. So this is actually an extension of the entity model, but I like to call it out because a lot of what we do in Managed Center is building charts and visualizations of data for customers. But as I mentioned, development bottleneck, right? If you need a new chart, you might have to wait a whole sprint, or you might have to wait 10 sprints because your chart's 50th in the queue, please hold. So we need to democratize the way that you can build the chart. And we do that by making it an entity. You define the query, you define the data source, you define the type of chart that you want to show. You define which filters we should show. And we build an engine that renders it. And then the action model, again, built on top of the entity model. Right? So we have this saying in the Managed Center team that it's great if you can scare the crap out by surfacing a piece of information they didn't know, like your critical router is currently down. But we actually had a customer come back to us and say, okay, great, you succeeded in scaring the crap out of me. What do you want me to do about it? Like, you've got to give me something to do once you've done that. So we have this phrase that, it's a cliche within the team, but it's actionable insights. There's no point surfacing a piece of information or data to the customer if they can't do anything about it, or if they can't see that you're doing something about it, in the case of their critical router being down, as an example. So the action model is an extension of the entity model. It could be as simple as defining a way that you escalate an incident ticket for a given customer. It could be you want to spin up a new VM because you've got a capacity incident, and the way you're going to solve that is, this is customer, click this button and you'll get a new VM. It'll go into your auto scaling group and off we go. Or it could be, I've got all this data about your SLAs that we've contracted to you for the last 12 months. But you need to take that data and mash it up with other vendors, present it back to your execs as to why Dimension Data NTT is such a great vendor to work with. So again, this is about taking things that currently have to be defined in the UI itself and letting it be defined by the teams that are actually delivering that value to customers. All right, well, that's pretty cool. Those are some nice boxes on a screen. But how do you make it real? So what I wanted to talk about today is some patterns and some tech that I think is pretty cool, that we think is pretty cool at NTT, that we want to use more of. So I mentioned the first a little bit earlier, micro front ends. The second is GraphQL. And the third is progressive web apps. So let's get into a little bit more detail about each of those and why we think they're cool. So micro frontends. So micro frontends, it's pretty much exactly what you would expect after you heard the term. It's just like a microservice, except for the UI. It's a little bit trickier in this case because micro doesn't necessarily mean small in this scenario. It's more about the logical decomposition, right? So your nav bar might be a micro front end. A chart might be a micro front end. The form that you use to log an incident might be a micro front end. So it's a self-contained piece of UI functionality that's paired with a corresponding microservice, backends for front ends, which is underpinned by a set of portal common services. And they're tied together in a parent shell, basically, that provides common services to those front ends. Things like authentication, routing, user preferences, am I light mode or dark mode? Those sorts of things. So there are some benefits and there are some challenges to this sort of approach. So the benefit, and this is a really big one, feature team can control the entire flow of data from where they're storing it through to the user interface. It's really important if you want to enable those teams to be self-managed and deliver value, by themselves. Teams, in theory, and I'll get to the theory in a sec, can write in whatever web framework they like, right? Just like we can write a microservice in Python, Node, .NET, whatever we like, and package it up. We can do the same on the front end. Smaller pieces of UI functionality can be reused between different portals. So I can build something, common navigation, and I can share it with all these different teams. And it skates to where the puck's going to be, right? Web components, it's very close to being a standard, and we will, we want to be ahead rather than behind. And they also come with some challenges. So you have to get the integration model into the parent app right. Otherwise, you're going to end up with a mess of components. It's great in theory that the teams can write in whatever web framework they like, but it's not so great for your app bundle size if you've got 3 different versions of React, 1 of Angular, and 1 of Vue, right? So governance and controls around, standards around what you're building is really important. And of course, styling can get really tricky with lots of components. Luckily for us, we have a solution to the styling problem, which we call Basecode. So Basecode is our living style guide. It's based on Bootstrap. It's essentially a Bootstrap theme. And it's born from the custom Managed Center user interface, but now used everywhere across the organization. So that's lesson 3. Having a living style guide makes the look and feel part of UX fantastically easy to share across teams. So it's really funny. I'll get an email invite to a half-hour call from a team based in Belgium, and they're like, "Oh, we've built this cool portal. We want you to have a look and see if there's stuff that you can use." And as soon as you open it up, it looks and feels exactly like every other portal because all they've done, they've downloaded Basecode, they've applied it, and instantly you've got the same look and feel everywhere. It also means that if you have to go through a rebranding exercise, like we are currently doing at NTT, that we update Basecode, the teams pull it, and all of a sudden their portals all look the same. It makes it so much easier to deal with that look and feel part and lets you focus on the actual experience, the actual flow of users between portals and between functionality. So micro front ends, why do we think it's cool? So they extend the same ideas in thinking about microservices to the front end. So we have a bunch of back-end devs, they're pretty excited about microservices. They think now in a microservice way. We want to extend those skills out to our front-end devs. Delivers the same benefits and challenges as microservices do. Contained functionality, you update small pieces of code, less likely to break, etc. And so how does it fit those concepts, those 3 models that I was talking about? So with the right standards, lets us decentralize development effort to the teams that are doing the services, rather than it being held in a central place. And it lets us share components between teams and other portals in the business more easily. So the second tech that we're really excited about is GraphQL. For those who don't know what GraphQL is, it's essentially an API query language that provides a type-based interface for accessing data whilst abstracting its sources. So it decouples your interfaces from your data, and it's aligned with how big web companies solve the enterprise service bus problem on the web. So it was built by Facebook, to offer as a common layer between their web app, their mobile apps, etc. So it lets you define types, routers, switches, incidents, changes, all of those entities I spoke about before. This is where GraphQL comes in. It's really, really cool. You can say a router is this, 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 and this. It's a name, it's an IP address, it's a location. You can define actions for those things. Update this incident, add a comment, escalate, etc. And it lets you define relationships. This CI lives at this location, which is for this customer. So it's a really powerful way to standardize the data model across multiple interfaces. So why do we think it's cool? It's fantastically powerful. You only get the data you ask for. Makes it easy to add new data sources or change them without impacting the front end. So because there's a decoupling layer between the UIs and the data, if I suddenly change where my router IP address comes from, I've got a new CMDB, that's completely invisible to the UI. And it makes it easy to mash up data from multiple sources. So I mentioned the example before where you have a CI and you have the performance data from that CI. So, obviously it's pretty unlikely you're going to have your time series data stored next to your CI in your CMDB, right? But using GraphQL, you can just say, well, performance metrics comes from this time series data store over here. CMDB information comes from ServiceNow. From the UI's perspective, they make one call, we mash it up, and they get the results. So how does it fit the concepts? Lets you define a single way of representing entities which can be shared across portals. So this gets back to that problem I was talking about where the customer calls us and says, I've got 9 incidents on this portal, but 12 on this one. What the heck are you guys doing? Provides a single consistent interface for accessing data from any data source. So now I don't have to talk Elastic API, ServiceNow REST, SQL, all that stuff. I just have to talk GraphQL and it worries about the rest. So the last technology I wanted to talk about is progressive web apps. So I won't go into too much detail here, but so progressive web apps are a technology coming out of Google. And they're a way basically to take your website and have it behave kind of like a native app. So that means that for us, instead of having a web team, an iOS team, an Android team, we have a web app team, and they can build in a way that can take advantage of native technology like push notifications, installation directly to the device, caching to device, so that if you're in an area with low connectivity, you can still use and interact with the application. So why do we think it's cool? It enables that app-like behavior without needing to have native apps and a shared code base. We don't need those phone OS teams. And how does it fit the concepts? Makes the content available on any platform, right? So our goal is to be where the customer is. There's no point being UX-driven, being customer-driven, if you're not available on the device that they like to use every day. It reuses the common services to deliver a consistent experience. And it can be refreshed with new technology since it sits on top of the business layer. So if we don't like our Angular app anymore, we can chuck that away. We can build React, we can build Vue, we can build whatever new framework they've released since I started this talk. So what does the future of portals look like at NTT? So we want to use GraphQL and custom microservices to create a single source of truth for data. We want to use that single source of truth to create micro front ends, which means we can have reusable components that can be shared across portals. When I build an incident chart, I can use it everywhere. We want to offer user customization. So when we've built all these micro front ends that are web components, we can have them in a list and a blank slate for the customer. They can drag and drop, hit save, and that's their interface to NTT. It's not what we think is important, it's what they think is important. We want to become more API driven. So not just exposing that data to our systems, but exposing that data to customer systems. And most importantly, we want to turn that data and information that we have and make it actionable for our customers. So that's it. Thank you everyone for your time.